Welcome to Science Access. In today's video, we'll be dealing with expansion of solid and liquid. In this video, we'll be talking about the introductory part of expansion, and we'll be doing some calculations. While in our part 2 of this video, we'll be doing more on calculations. Now, expansion. What is expansion? Expansion means an increase in the size of an object, or you can say an enlargement in size of an object. Like for example, now rubber, when you expand it, the process by which you expand a rubber is called expansion. And please note, um, heat heat cause expansion in solid. Like for example, now your metal, when a metal is heated, it causes an expansion in that metal. Now we move on to the advantages of expansion. We have the fitting of wheel in rims, we have the expansion of metals used in bimetallic thermometer, and we have the red hot rivet in ship. Now these are some of the advantages of expansion. Why disadvantages of expansion? We have expansion in railway track, we have the bursting of water pipes, we have the expansion of metal or concrete bridges, we have the cracking of glass cup containing hot water. These are some of the disadvantages of expansion. Now we move to forms of expansion in solid. We have three basic forms of expansion in solid. We have the linear expansion, we have the area expansion, and we have the volume expansion. In this video, we'll be taking only the linear expansion, while in the part 2 of the video of this video, we'll be taking the area and volume expansion. Now, linear expansion of solid. When a solid is subjected to a rise in temperature, its increase in length is nearly proportional to its initial length multiplied by the angle multiplied by the change in temperature. Now, this is just telling us about the formula, how to derive the formula. That is, when a solid is subjected to a rise in temperature, its increase in length, that is increase in length. This is the increase in length. Is nearly proportional to its initial length multiplied by its change in temperature. That is initial length multiplied by change in temperature. So they're just telling us about they're just telling us about the formula. So linear expansivity. Linear expansivity is defined as the increase in length per unit length per degree rise in temperature. That is the definition of linear expansivity. Now, the formula for linear expansivity. Note, linear expansivity is we use the symbol alpha to denote linear expansivity. So linear expansivity is equal to change in length over L1 times angle theta. Note, change in length can also be L2 minus L1. L2 represents final length. L1 represents initial length. So here L1 too, L1 represents initial length. Theta 2 represents temperature at final length, while theta 1 represents temperature at the initial length. Why this theta, like I said, is the coefficient of expansivity of solid. That is in linear expansion. So that is just about the formula of linear expansion. From this formula, we can derive our formula for length if we are given some questions on to find the length of a solid. So we can derive our formula from here, which is what we do here, we just cross multiply. So this one equal to this one times this one. So we have L2 minus L1 then equal to then L1 bracket theta 2 minus theta 1. So we take this one to the other side. So we have L2 equal to L1 plus theta L1 theta 2 minus theta 1. So we have L2 equal to L1 in bracket 1 plus this theta 2 minus theta 1. So this is the formula we derive to get the length of a solid. Now, let's take examples. Let's take some examples on linear expansion. So, number one says a 20-meter length of wire experiences 0.020 meter change in length when heated for a temperature of 5 degrees Celsius to 55 degrees Celsius. Now, the question says calculate the linear expansivity of the wire. Now, note, if you want to calculate any question on linear expansivity, we have to bring out the parameters first to make your solving easier for you. Now, from the question, a 20-meter length of wire, we know that that is our initial length. So we take our L1 as 20 meter. Then experiences 0.020 meter change in length. So our change in length is 0.020 meter. Then for a temperature of 5 degrees Celsius to 55 degrees Celsius, so that will be our theta 1, which is 5 degrees Celsius, then our theta 2, which is 55 degrees Celsius. Then calculate the linear expansivity. So linear expansivity is what we are looking for. So then we solve. We have brought out the parameters, so we solve. Using our formula, linear expansivity equal to change in length over L1 in bracket theta 2 minus theta 1. Now, our linear expansivity, from our formula, what is our change in length? As you can see, our change in length is 0.020 meter. So, which we have here. Our L1, what is our L1? Our L1 is equal to 20 meter. So we have it here. What is our theta 2? Our theta 2 here is 55 degrees Celsius. So we have it here. Then our theta 1 is 5 degrees Celsius. So we have it here. So what do? We solve. So our 0.020 will come down over 20. This 20 will come down. Then 55 minus 5. We solve the bracket first. 55 minus 5 is equal to 15. Then what do we do next again? We can still multiply the down part. So we have 0.020. 20 times 50, we have 1000. So 0.020 over 1000 is equal to, or you can still say 0.020 over 1000 equal to 0.0001234 Okay, so we can still say 0.020 divided by 1000 is 0.00005. Now you use in your standard form, we have 2.0 times 10 raised to power minus 5. Now let's move to example 2. A metal rod of length 50 cm is heated from 40 degrees Celsius to 80 degrees Celsius. If the linear expansivity of the metal is alpha, calculate the increase in length of the rod in meters in terms of alpha. Now, like I said before we calculate on linear expansivity, we have to bring out the parameters to make our solving easier for us. So, in our parameters, what is our length? Our length is 50 cm, which is our L1. So, but they said we should convert in meters. So we said 50 divided by 100 is 0.5. So our L1 is 0.5 meter. Then our theta is 40 degrees Celsius for theta 1 and 80 degrees Celsius for theta 2, which we have here. Then they said we should calculate the increase in length of the rod. So that's what we are looking for here. Now, remember our formula for linear expansivity is change in length over L1 in bracket theta 2 minus theta 1. Now, but they say we should calculate we should calculate the increase in length of the rod. Now, this is our increase in length. So what do? We cross multiply. So we say our increase in length is equal to alpha times L1 in bracket theta 2 minus theta 1. So this is how we got this our formula here, like this. So what's our alpha? They did not give us. Our change in length. What is our change in length? No. Okay, our alpha. They did not give us alpha. What is our length? Our L1. Our L1 is 0.5, which you have here. Then our theta 2. What is our theta 2? Our theta 2 is 80 degrees Celsius, which you have here. Then our theta 1. Our theta 1 is 40 degrees Celsius, which you have here. So what do? We multiply. We multiply our alpha times 0.5 times 40. So our final answer for finding the increase in length of the rod is 20 alpha. Remember, they said in terms of alpha. So our answer is 20 alpha. Now let's move to number 3 question. A metal rod of length 100 centimeter is heated through 100 degrees Celsius. Calculate the change in length of the rod. Here they gave us our linear expansivity of the rod as 3.10 raised to power minus 5. Now in the question, what is our length? Our length here is 100 centimeter. Our length is 100 centimeter. Our change in temperature 100 degrees Celsius, which you have here. Then our linear expansivity that they gave us is 3 times 10 raised to power minus 5, which you have here. Remember I said we have to bring out the parameters before we can solve the question to make our solving easier for us. So they said we should calculate the change in length of the rod, like we solved in our number 2. Change in length. We brought out the formula here, then we cross multiply. So our change in length equals to theta, then L1 times our change in temperature. Then we bring our parameters here. So what is our theta? Our theta is 3 times 10, 3.0 times 10 raised to power minus 5, which is here. What is our L1? Our L1 is 100 centimeter, which is here. Then our change in theta is 100 degrees Celsius, which is here. So if you multiply 3.0 times 10 raised to power minus 5 times 100 times 100, then we have our final answer for change in length as 0.3 centimeter. Now let's move to the number 4 question. A metal rod of length 40 centimeter at 20 degrees Celsius is heated to a temperature of 45 degrees Celsius. If the new length of the rod is 40.05 centimeter, calculate its linear expansivity. This one is straightforward. They are just asking for the linear expansivity here. So we just have to put from the formula, just have to solve from the formula. But first, we have to write out our parameters. So what is our length in the question? Our length is 40 centimeter, which we have here. Then at 20 degrees Celsius, so we take 20 degrees Celsius as our theta 1, which you have here, 20 degrees Celsius. So they say it's heated to a temperature of 45 degrees Celsius. So we take our theta 2 as 45 degrees Celsius. Then if the new length of the rod is this, so our new length, we take our new length as our L2 as 40.05 centimeter, which we have here. Then they said calculate its linear expansivity. So we all know that our formula for finding linear expansivity is L2 minus L1, which is also the same thing as change in length, then over L1 theta 2 minus theta 1, which is also known as change in theta. So finding our answer to this question, what is our L2? In our parameter, our L2 is 40.05, which we have here. Then our L1, what is our L1 here? Our L1 is 40 centimeter, which we have here. So our L1 is still the same thing, 40 centimeter. Then our theta 2, what is our theta 2 in the question? Our theta 2 is 45 degrees Celsius, which we have here. Then our theta 1 is 20 degrees Celsius, which we have here. So what do we do here? We solve for the bracket first. So 45 minus 20, no, we solve for this one first. 40.05 minus 40, we get 0.05. Then over, we bring this 40 down. 45 minus 20 is 25. So 0.05 over 40 times 25. That is equal to 0.05. 40 times 25 is equal to 1,000. So 0.05 over 1,000 is equal to 0.00005. Now, taking this to standard form, we have 5 times 10 raised to our fifth. 5 times 10 raised to power minus 5. Then Kelvin. Please note that this Kelvin must be added. This is the unit for linear expansivity. Kelvin. That's the unit for linear expansivity. Now we move to number 5 question, which says if a 40 centimeter brass rod experiences a 5 degrees Celsius difference in temperature when heated, what will be the change in length of expansion experienced by the rod? Our linear expansivity was given to be 1.9 times 10 raised to power minus 5. So we solve. Remember I said we'll bring out our parameters first. So what is our length there? So our length is 40 degrees and 40 centimeter. So we have it here, 40 centimeter. Then our they said 5 degrees Celsius difference in temperature. So that is our change in temperature, which we have here as angle theta equal to 5 degrees Celsius. Then they gave us our linear expansivity of the brass rod as 1.9 times 10 raised to power minus 5, which we have here. So they said we should find the change in length of expansion. So that is what we are looking for here. So to find the change in length, we use from our formula equal to change in length over L1 in brackets angle theta. Please take note that our angle theta is still the same thing as theta 2 minus theta 1. So that's how we got angle theta. So we are looking for change in length. So what do? We cross multiply. So our change in length is equal to this times L1 in brackets angle theta. So that was how we got this our formula here. So now what's our alpha? Our alpha is 1.9 times 10 raised to power 5. That is our linear expansivity they gave us. 1.9 times 10 raised to power minus 5. What's our L1? Our L1 here is 40 centimeter, which we have here, 40 centimeter. Then our change in theta, that is 5 degrees Celsius, which we have here. So multiplying 1.9 times 10 raised to power minus 5 times 40 times 5, we have our change in length to be 3.8 times 10 raised to power minus 3 centimeter. So that's our final answer for finding the change in length of expansion. That is our final answer to this question.